video, we're going to take a look at sampling distribution of sample proportions, and specifically an example here. So let's read through this problem, let's get to it. So a report states that 72% of all high school students in the U.S. attend prom. As part of a study for a stat class, you collect a random sample of 200 students and find out how many attended prom. What's the probability that at least 150 of the 200 students attended prom? So essentially what we're doing here is we have information about a population, okay? And we want to see how does my sample, what is the probability my sample meets certain conditions? Specifically, what's the probability that my sample, at least 150 of the 200 say, yeah, I'm going to be attending prom. So we're comparing our sample, hopefully against a bunch of other samples, which is a sampling distribution. Now I do have some work down here, but that was just to kind of speed things up in this video. The first thing I would do is I'll probably figure out what do these numbers mean up above. So first off, I see a report states that 72% of all high school students in the U.S. attend prom. That is your population proportion P. So I'm going to put P equals 0.72. The next thing I see is it's talking about, as part of the study, you collect a random sample of 200 students. That is my sample size, so N equals 200. And then finally, as you read through it, they have the actual question part. What's the probability that at least 150 out of the 200 students attend prom? That is your sample proportion. So 150 out of 200. So that is a p hat is 150 over 200. Once I have those pieces of information, then I'm going to go and tackle some conditions there. So these conditions, these need to be true before I can do anything else with this problem. We'll talk about why here in a second. So the first thing I check is there independence? So how do you check that? You check, was the sample randomly selected? So the sample of 200 was randomly selected. Great, we have independence. Next, I check the 10% condition. I want my sample not to be too big. So the sample needs to be less than 10% of the population. So if my sample is 200, and that was exactly 10% of the population, that means my population, I hope, is bigger than 2,000 high school students. That is true. So the sample of 200 is not more than 10% of the population. Finally, we check NP is greater than or equal to 10 and NQ is greater than or equal to 10. We're making sure our sample is big enough. So using that information I found earlier, I already did these calculations. N times P is 200 times 0.72, which is 144, which is definitely greater than or equal to 10. Q is just the opposite of P. Okay, it's 1 minus P. So 200 times 0.28 is 56. That's also greater than or equal to 10. The reason we have to check these conditions is because of these, we now know my sampling distribution is approximately normal. Okay, my sampling distribution is approximately normal. If my sampling distribution was not approximately normal, pretty much everything would stop. There is nothing we could do, okay? So we need these conditions to happen so that the sampling distribution is approximately normal. It opens up a whole bunch of options of things we can do. So now that I know my sampling distribution is approximately normal, I drew my approximately normal distribution. Let's find the center of this sampling distribution of sample proportions, so mu of p hat. And let's also find the standard deviation, which is sigma of p hat. What we know is the center is always p. So the center of my sampling distribution is p, which we said earlier was 0.72. To find the standard deviation of a sampling distribution of sample proportions, it's the square root of p times 1 minus p, which is the same as q, divided by n, which is 200. Okay, and I already did this calculation quickly off screen to try and speed things up. Carefully type that all in if you need to check it. I'm going to round it to 4 decimal places, 0.3175. Okay, so now I know my sampling distribution has a center at 0.72, and I know the standard deviation of the sampling distribution is 0.3175. Okay, so let's get to actually tackling the question here. Okay, I have my distribution. They want to know what's the probability that at least 150 of the 200 students attend prom. If we're talking 150 out of 200, that's a p hat. That's 0.75. So my cutoff point, 0.75, would be over here to the right about here, 0.75. And they want to know what's the probability that at least 150 of the 200 students attend prom. So that means I want the area above. From here on out, we're doing kind of some z-scores, which at this point in time, you should know how to do them. You could do them pretty fast. So I'm not going to spend an alarming amount of time on this because you should know how to do it. So our z-score is our observed, which is 0.75, minus the expected, which is 0.72, divided by our standard deviation, which is 0.3175. You could do that calculation. I would round it to 2 decimal places. It's 0.09. You would then go to a z-score table, something like this, yeah? Look up your 0.09. So I'm trying to find the probability or the proportion of z-scores that are greater than or equal to 0.09. Now do remember, z-score table always gives you the area to the left. So whatever number we look up when we find 0.09, we need to subtract that from 1. So I went ahead and already looked this up for us. It's 0.5359. You subtract that from 1, you get 0.4641. We're almost there. Just got to tie everything together through context. So I'm going to say, what does this 0.4641 mean? And tie it into the problem. So really, I'm kind of restating the problem. So what this means is there's a 46.41% chance that at least 150 of the 200 students attend prom. And that, my friends, is entirely a sampling distribution of sample proportion problems. Write out your information. You have to have these conditions. Without these, none of this down here exists. Have your conditions so you know things are approximately normal. Find your center, standard deviation, get your z-scores and context. That's sampling distributions of sample proportions. I'll have another follow-up video that will look at sampling distributions of sample means.